We're going to do some practice with monatomic formulas with main group elements. We're going to write the ionic formula from the name, and then we're going to split up the formula into cations, anions, and find the total number of ions. So let's start with potassium bromide. So potassium is written first, which means it's our cation. The symbol for potassium is capital K. And since potassium is in group 1A, it means it has one valence electron, so it forms a +1 charge. Remember, we don't write the 1. The fact that we wrote plus means that it is at least 1. Bromide is the anion, and remember the ending changed to "ide" for our name. So we look at the root for what element that is. So brome, like bromine, is our anion. So Br is our symbol. For bromine, it is a -1 charge because it is in group 7A, and so it only needs one more to get to 8. So if we crisscross these or we write our ionic formula, remember the positive one goes first, and this is a 1-to-1 ratio. So K, B, R. No spaces, just stick them together, and then the R is lowercase. So this is your ionic formula for potassium bromide. Now let's look at calcium oxide. So the calcium is written first, and that's our cation. Remember, cations are positive, anions are negative. Okay, so calcium is Ca. It's in group 2A, which means it has a 2+ charge. And we know this because the calcium is a two valence electrons to give away. Oxide, the ending changes to "ide, so we need to look at the root, ox, which comes from oxygen. Okay, oxygen is in group 6A, which means it has a 2- charge because it has 6 and it needs 2 more. So if I write the ionic formula, the positive one goes first. This is again a 1-to-1 ratio. Okay, or if I crisscross these, I'd have Ca2O2, which reduces to CaO. Next up is magnesium fluoride. Magnesium is Mg. It's in group 2A, which means it has a 2+ charge. And again, we write the 2 and then the plus. And then fluoride, we look at the root, fluor, like fluorine. So that's capital F. That is in group 7A. So fluorine has a -1 charge. Okay, and if I crisscross these, or if I look at the ratios, Mg is a 2+, F is a 1-. So in order to have a net neutral compound, I would need 2 fluoride ions for every 1 magnesium. So I can crisscross these or think about this like ratios, and I would get MgF2. Okay, strontium iodide. So strontium is Sr, and strontium is in group 2A, which means it has a 2+ charge because it has 2 valence electrons to give away. Iodide, the root is iodine, okay, or iodine, excuse me, capital I. And I like to make it really look like an I because it might get confused with the lowercase l. So I try to make it look like the capital I. And it's a -1 charge because it's in group 7A. So this is kind of like the one before it where we have a 2+ and a 1-. So in order to get a net neutral compound, we would need 2 of the minuses to add to 2+ to be 0. And if we crisscross these charges, then it'd be Sr, and there's one of them, I2. Last one is aluminum oxide. So aluminum is Al. It's in group 3A as a metal. So we'll give away those 3 electrons and form a 3+ charge. Oxide, again, the root is oxygen, so O, capital O. And then it's in group 6A, so its charge is 2-. So I can crisscross these charges or think about this in trying to make a net neutral compound. So you would look at the closest common multiple between 3 and 2, and that'd be 6. So if I crisscross this 2 drops down to the aluminum, the 3 drops down to the oxygen, Al2O3. Okay, and another way to think of that is I would need 6 pluses and 6 minuses in order to make this a net neutral compound, and that's what I have over here. Next, we're going to take the formula and we're going to split it up into cation, anions, and the total number of ions. Remember, cations are positive, anions are negative, and the total number of ions is how many we have total, okay? So if I look at KCl, I'm going to split this up wherever I see a capital. So K is a capital and C is a capital. So I'm going to draw a dividing line right in between those two. That tells me where my cation is and where my anion is. So my cation is positive K because it's written first, and my anion is Cl for chlorine. Okay, so now if I look at my charges, we know that potassium is in group 1A, so it always has a 1 plus charge. And we know chlorine is in group 7A, which means it always has a 1 minus charge. In terms of coefficients and how many there are, well, there's no subscripts in my formula, which means I only have one of each kind of ion. So it's kind of like there's a coefficient of 1 in front of each of these, but we don't write it because just like in math, if you have 1x, you don't write the 1. The fact that you wrote K plus or Cl minus means that there's 1. So the total number of ions here is 2. There's 1 K plus and 1 Cl minus. Okay, let's look at the next one, BaO. Again, I'm going to look for the capitals and draw a line because that's where I'm splitting up between my cation and my anion. So Ba and I'm going to split it right in between the lowercase a and the uppercase O, which tells me Ba is my cation and O is my anion. So Ba is in group 2A, which means it has a 2 plus charge. Oxygen is in group 6A, which means it has a 2 minus charge. Be really careful that you don't automatically just put +1 and -1, because here it's a 1-to-1 ratio, but the charges are 2 plus and 2 minus. There's also no subscripts. So again, that means there's no coefficients that we write out. Really, there's one of each. So my total number of ions, again, is 2. Okay, here we go. This one has a subscript. So Na2S, again, I look for the capital versus the lowercase, and that's where I'm going to break it up. So Na2S. So this 2, I'm going to pull out in front because it's telling me that I have 2 of the NAs. So I have 2 sodium ions. So I'm writing that here just like I would in math for 2x. Sodium is in group 1A, so it has a +1 charge. My anion is what's on the right side of the slash, and that's sulfur. It's a sulfide ion. It's in group 6A, which means it has a 2 minus charge. Now, how you can tell if you're doing this right is if it adds up to 0. 2 plus and a 2 minus equals 0. So that tells me that I'm doing this correctly. So my total number of ions is how many there are. Well, I have 2 sodiums and 1 sulfur. So 2 plus 1 is 3. So there are 3 total ions. Move this over a bit. Okay, next one. Ca3P2. Okay, so calcium phosphide. So again, I'm looking for that capital. We got a lot of subscripts here. So I'm going to break it up right there, wherever I can break up my cation from my anion. I'm going to take this 3 as my subscript because it's telling me that there are 3 calcium ions. So 3 calcium ions. And I know what the charge is because it's always the same for main group elements. Calcium's in group 2A, so it's a 2 plus charge. Okay, and I have 3 of them. That's what that subscript 3 means. 2 phosphide ions, 2P. I'm pulling out that subscript as a coefficient because I have 2 of them. And I know the charge because it's always the same for main group elements. Phosphorus is in group 5A, which means it has a 3 minus charge. And again, you can check to see if you're doing this right, is if your positives and your negatives add up to 0. So 6 pluses, 6 minuses, so in total that'd be 0, a net neutral compound, which means I'm doing this right. So my total number of ions is how many ions there are in this compound. So I have 3 Ca2 pluses and 2 Pl3 minuses, so 3 plus 2 is 5. Okay, last one, BaF2. So I'm going to break this up. Ba and F2. Ba does not have a subscript, which means there's only one of them. So barium is in group 2A, so it has a 2 plus charge. And then F2 for fluorine, the 2 tells me there are 2 of the fluoride ions. And I know what the charge of fluoride is because it's always the same. It's in group 7A, so it's a -1. And again, 2 plus and 2 minus is a total of 0, which means that we're doing this right. So my total number of ions is, well, I have one Ba2 plus and I have two F minuses, so 1 plus 2 is 3. And there's our practice of forming the ionic formula from the name and then splitting up the ionic formula into cation, anions, and total number of ions.